Hey everybody, thanks for checking out another math video here about solving quadratic inequalities. This is the second video that I'm making about this topic, and this one's going to focus a little bit more on graphing as a way of finding the solutions to these inequalities. The first video, just to remind you, was more of a kind of a classic textbook approach to doing this, which I will recap right now with this example. So let's say we're going to solve the inequality x squared minus 5x plus 6 is greater than or equal to 0. So the other method that I showed you in that previous video had us taking that as if it were an equation, solving it to find the zeros of the function, and then we took those zeros and put them on a number line. After that, we tested a number from one of those intervals. You can see now the number line is divided into 3 intervals. One of those, or maybe 2 of those, will be our solution to the inequality. So I tested a number from the central interval there in the equation itself, and I ended up with a false statement. 2.5, which is a number in between 2 and 3, does not make a true statement, and therefore that interval is not the solution interval that we're looking for. So what it means then is really that the solution intervals are the other two. X greater than or equal to 3, and x less than or equal to 2. Those are the solution intervals. And here I'm showing you both two different ways of expressing that solution, once with inequality symbols and once with interval notation. Okay, so that was a pretty fast recap of that process there. So let's try again the same inequality, since we already know what the solution is, but now look at it in terms of a graph. So if I just graphed that parabola, y equals x squared minus 5x plus 6, you might start off by drawing your x-axis, maybe locating the x or the y-intercept there, and then once again doing a little bit of factorizations to come up with the x-intercepts of the graph, and there we go. We have a decent, although not super accurate, but a decent enough sketch of that parabola. Okay, so here's where I want to make just kind of a couple of general points here. Number one is that the the inequality that we're looking for here has greater than or equal to 0. And on a graph, the y values of that graph are greater than 0 when the graph is above the x-axis. So all that space there on the curve that you see that is above the x-axis, all of those y values of each one of those infinite number of little points, the y values are positive. They're above the x-axis. They're greater than or equal to 0. All right? And so what we are looking for, the solution intervals to our inequality, will show the x values that make those y values go above the x-axis. So we're expressing the solution there in terms of x, but it's related to the behavior of the y values, okay? And so when you look at that, there's the y values going above the x-axis to the right of 3 and to the left of 2, and therefore our x values that make that happen are the same place, to the right of 3 and to the left of 2. So our solution, once again, same solution, of course. X is less than or equal to 2, and x is greater than or equal to 3, and there's our interval notation style. All right? So let's try this a couple more times here in this video. Hopefully this will be kind of clear to you. All right? So let's try a different one. This one, negative x squared plus x greater than 0, plus 12 greater than 0. Okay, so let's think about the graph of that. And you know what, guys? We've got some great graphing technology right at our fingertips, and I don't mind at all if you use a grapher, some kind of graphing calculator, to get your graphs. As long as you can make sure that you know exactly what those x-intercepts are, the graph could be fine. You might have to do a little bit of algebra just to verify, but there you go. The graph is fine. And you can see real clearly, once again, we are looking for x values that make the y values go above the x-axis because it's greater than 0 inequality. Well, look, it's really obvious. Those x values in between 3 and 4 are where the y values go above the x-axis. There's our solution without doing any more work there. Negative 3 less than x less than 4, that's the inequality symbol notation. And then the interval notation there, it looks like a point coordinates, doesn't it? This looks like an xy point, but the context here would indicate that this is an interval, not a point. All right, negative 3 to 4. Let's do another one. This one is kind of a funny looking little inequality there, 7 minus x squared less than 0. And if I thought about what the graph of that looks like, I might write it in my graphing technology machine as y equals negative x squared plus 7. I've got some decimal looking values there for those x-intercepts, so I think I would recommend once again doing a little bit of algebra. Let y equals 0, solve it for x, and we've got plus or minus the square root of 7. Okay, so those are nice exact expressions for those x-intercepts. Well, once again, look at the graph. And this one is less than 0, so what we're looking for are x values that make the y values go below the x-axis in this case. All right? Well, it's still very easy to see. To the left of the left x-intercept and to the right of the right-hand x-intercept, that's where the graph is below the x-axis. Therefore, our solution is easy to come up with. X is less than negative square root 7, or x is greater than positive square root 7. And once again, there's our interval notation style expression. All right? So hopefully that was enough to give you a little bit of a boost along with the class discussions that we've been having. But if you haven't had any discussions in your math class yet, I hope this video was helpful to you. Thanks very much for watching, and I hope you're doing well, and I hope to see you soon. Bye-bye.